Here is another question on kinematics of a particle. A car moves in a three-dimensional space such that for a short time, its velocity is given by this. Okay, this vector. This is a vector, where t is the time in seconds. We are to determine the position and acceleration of the particle in 2 seconds. Velocity is the rate of change of distance with time, right? Okay, so since we are talking about position here, the velocity vector is the rate of change of the displacement vector, okay, with respect to time. It's as simple as this. So this is V. I want to write this as a column vector. That is a vector that has 1 column. V is 3t squared plus 5t, 2t plus 3t cubed, t plus 5t squared. Alright, meters per second. So let's leave the unit first. So in place of this now, I want to put this here. So the arrow dt, okay, is this as 3t squared plus 5t, 2t plus 3t cubed, t plus 5t squared. So let's separate the variables. This is a vector, okay, in terms of t. Let's take the t to this side by cross multiplying. 3t squared plus 5t, 2t plus 3t cubed, t plus 5t squared, okay, dt. So to get the position, we'll integrate both sides, okay? So integrating both sides, we have this. Let's integrate this with respect to t. So integrating this, we have this, all right, equal to, let's integrate this. This is 3t cubed over 3 plus 5t squared over 2, right? This is 2t squared all over 2 plus 3t to the 4th all over 4. And we have, this is t squared upon 2 plus 5t cubed upon 3. And we'll add a constant vector to it, c1, c2, c3. So to determine the constants, okay, c1, c2, and c3, we need a value for t and we need a position vector. Since the question didn't give us an initial condition, what we do here is to assume that t is equal to 0 and this position vector is also 0. That is t equal to 0 and arrow is this 0, 0, 0. So let's plug this here. We have 0, 0, 0 equal to, if I put 0 for t here in this vector, everything will be 0, 0, 0, 0. So I'm having 0, 0, 0 plus the vector c1, c2, c3. And it is obvious that c1, c2, c3, they are also 0. 0, 0, 0 minus this 0, 0, 0 is equal to c1, c2, c3, which is 0, 0, 0. Okay, so the constants c1, c2, and c3 that form the constant vector, they are what? 0. Arrow, the position vector is, since everything here is 0, we just write this down. All right, this is 1, that's t cubed plus 5 over 2t squared. All right, this will cancel out. T squared plus 3 over 4t to the power 4. T squared plus 3 upon 4, t raised to the power 4. This is t squared over 2, t squared upon 2, plus this, plus 5 upon 3, t cubed. This is the position of the particle at any time t. The question says when t is equal to 2 seconds. So when t is equal to 2, all right, the position of the particle is this. Let's plug into here. That's 2 to the power of 3 plus 5 upon 2 into 2 squared. This is 2 to the power of 2 plus 3 upon 4 into 2 to the power of 4. All right. This is 2 to the power of 2 upon 2 plus 5 over 3 into 2 raised to the power 3. So what's this equal to? This is 8. 2 squared is 4. 4 divided by 2 is 2. So 2 times 5 is 10. So 8 plus 10 is 18. This is 4. 2 to the power of 4 is 16. 16 divided by 4 is 4. 4 times 3 is 12. 4 plus 12 is 16. 2 squared is 4. Divided by 2 is 2. 2 to the power of 3 is 8. Alright, 8 times 5 is 40. That's 40 over 3. So if we simplify this, 3 times 3 is 6. 6 plus 4 is 46. That's 46 all over 3. So this is the position of the particle in meters. That is when t is 2 seconds. Now, what is the acceleration of a particle when t is equal to 2? Let's determine that. So this is the velocity vector that we're giving. So writing this as a column vector, we have 3t squared plus 5t, as I did earlier, 2t plus 3t cubed, t plus 5t squared. Okay, let's neglect the unit first. Okay, acceleration is what? Is the rate of change of velocity with time. Okay, so this is it. So to get the acceleration, we need to differentiate the velocity with respect to time. So let's obtain the v dt. So let's differentiate this velocity vector now. Differentiate 3t squared with respect to t, we have 60, and differentiating this with respect to t, we have 5. So differentiating this with respect to t, we have 2, and here we have 9t squared. So if we differentiate this, we have 1 plus 10t, right? I just differentiated this vector, and this is what I have. So this is what the acceleration is equal to. That is, the acceleration vector is this: 6t plus 5, 2 plus 9t squared, 1 plus 10t. So what is the acceleration of the particle when t is equal to 2 seconds? So when t is equal to 2, the vector is this: 6 into 2 plus 5, okay, plus 5, 2 plus 9 into 2 squared, 1 plus 10 into 2. So what will this give us? This is 12. 12 plus 5 is 17. 2, alright? This is 4. 4 times 9 is 36. Plus 2 is 38. 20 plus 1, 21. 1 meters per second squared. And we can write this as 17, 38, 21 meters per second squared. This is the acceleration of the particle. Okay? The same thing here, we can write it like this also. The position is 18, 16, 46 upon 3 meters. So this is it for this particular problem, alright? I hope you enjoyed the video. Keep supporting by subscribing to this channel. Like and share the video to your friends and to your classmates.